Well, my name is Esteban, and today I will be talking about hacking and protecting Oracle database vault. This is the outline of this presentation. First, we are going to see an introduction to Oracle Database Vault. This is quite a new topic for this kind of conferences, so I will be doing an introduction of what is Oracle Database Vault, what changes it introduces, and what are its elements. Then we're going to move to the most important part of this presentation, that are the attacks against Oracle Database Vault. We're going to see attacks that will look for operating system access in order to be able to compromise Oracle Database Vault and the Oracle database. We are going to see how to impersonate the Maxis user, that is the most important user in Oracle Database Vault, is the Database Vault owner user. Then we are going to see some special considerations for the sys user and how we can compromise Oracle Database Vault using SQL injection vulnerabilities in the sys schema. After that, we are going to see some issues with native database auditing with the sys user. Finally, we are going to see some additional protections and some conclusions. Well, what is the Oracle Database Vault? It's important to know that it's an add-on to Oracle Database. It's not installed by default. It's installed mainly to add security features that doesn't have the database and that are required, for example, for strict regulations such as Sarbanes-Oxley or PCI that calls for separation of duty, a strict separation of duty inside the database. So Oracle Database Vault will allow for separation in activities such as account management, database resource management, and data security. It's this add-on product protects against attacks that can be done by highly privileged users, such as database administrators. So now the DBA doesn't have the unlimited access to database data. After we install this add-on product, there are some changes in the configuration of the database instance. The first thing that you can notice is that initializations parameters are changed to more secure values. This is documented in the Oracle Database Vault documentation. The recycle bin feature is disabled. Some privileges are removed from default Oracle roles like DBA role because some of these privileges could lead to the compromise of Database Vault security features. Also, the database native audit is configured to include more actions, but actually the auditing is not enabled. Also, there are some architectural changes, like the sysout dollar table is moved to the system schema and instead of the sys schema. Well, but all these changes are not that doesn't add any security feature. It can be done just by any database administrator to any database instance. What are important changes are some protections that are added. For example, there are some schemas that are protected by default with Realm. We are going to see later what is Realm. So the sys and system schema are protected. as well as some sensitive commands like the commands that that are related to account management. For example, create user, alter user, etc. All these changes are incompatible with some operations of the database, like installing patches. So it is required to disable Database Vault when we want to install patches. Oracle documentations state how to disable Oracle Database Vault in order to install the patches, and that is what is found in the documentation. For Windows, we can rename a DLL file, and on Linux and Unix systems, we should execute a couple of commands to disable Database Vault. There are some other changes that older releases that were in place in older releases, like the operating system authentication to the database disabled, and that login with sysdba privileges were blocked. This, of course, had a lot of problems and incompatibilities with some of the tools like Arman and some other Oracle command line utilities. But there is a parameter in Oracle PWD tool to enable the sysdba access, as well as overwrite the sys password. So as you can see, if we have operating system access as the Oracle user, we are able to disable Database Vault, and also we can override and enable the sysdba access. Well, now let's see what are the elements that are provided by Database Vault that one can use to secure further the database. The most important concept probably are the realms, that are a functional grouping of database schemas and roles that we want to secure, for example, when they are related to accounting or employees. So you can use a realm to control the use of the system privileges to a specific account or role that are part of this realm. So even if we have, for example, select any table privilege or update any table privilege, we won't be able to access an object that is protected by a realm. Then we also have the factors that are named variables or attributes, such as IP addresses, user locations, or session usernames. These factors can be used to control the access to the database. This can be used to provide protections against application bypass or ad hoc database access. Then we also have some other concepts that we can use to further protect the database. Also, there are some schemas that are installed when we apply when we install this add-on Database Vault product. The most important one is DVCs, that contains all the Database Vault objects, such as the tables, views, and PL/SQL packages that we can use to administer and configure the Database Vault installation. This schema, of course, is protected by a realm so that administrators can't access it. The DBF schema, that is also part of Database Vault, is used to retrieve factor identities. It has functions to retrieve IP address, session username, etc. There are some roles that are provided by Oracle Database Vault that we can use to give the necessary authorization to administer or to use Database Vault. The most important role or the most full privileged role is DB owner. And we also have a DB realm owner that is an owner of a realm, but DB owner is the owner of all the Database Vault. So it's the most privileged user. Then we have a DB account manager that is used for account managing. It can create users or alter user passwords. Then we have DB sec analyst that is a role that allows to run reports of Database Vault. There are some users that are created when we install the Database Vault. This is asked, the user is asked for the usernames and password when one is installing Database Vault. So actually the usernames in a installation can be different than the ones that I use here in the presentation, but these names are the ones that are used through the documentation. So we have an account for the Mac account, that is the account responsible for the administration of database account. We must use this account to create or manage users. And then another important user is the Maxis user, that is as I said before, is the Database Vault owner. So it has permissions over the Database Vault realm. That is the one that protects the DVC schema that contains all the database objects of Database Vault. Well, there are some security considerations that are documented. Here I enumerate a few. This presentation is not going to focus on these documented considerations. There are some considerations with PL/SQL packages, such as UTL file. One can imagine that this is because this can provide file system access to anyone that has access to these PL/SQL packages. Also, it is documented that there are some privileges that can lead to the compromise of Database Vault, such as the one that are related to shop management, the recycle bin, and the external procedures. And there are also some trusted accounts that must be secured. The documentation said that the Oracle software owner and the sysdba users are accounts that must be trusted. Well, now let's see what are the attacks that we can do to compromise the Database Vault. First, there are the operating systems attacks, the attacks that will look for operating system access, being a user connected to the database. So we're going to see some examples of this. Also, we are going to see that it is possible with a couple of system privileges to create and execute a procedure in the Maxis schema and impersonate the Maxis user. We are going to see that the sys user can bypass the Database Vault, and we are going to see that impersonating the sys user through SQL injection, we can compromise Database Vault. Also, we are going to see some vulnerabilities that are specific to Database Vault. Well, let's see some ways to get operating system access through the database. This operating system access as the Oracle software owner or as root or administrator user in Windows, allows an attacker to disable Database Vault, and additionally to overwrite the sys password and enable the CTBI connections if they are disabled. There are many ways in which an attacker could get operating system access. There is the external procedure call method. The following example is about this method. We are going to see also that exploiting a buffer overflow vulnerability can allow for operating system access and the disable of Database Vault. Also, it is possible to use Java store procedures to get operating system access, and also through external shelves and creating a directory object could also lead to file system access and the compromise of Database Vault. In addition, if we don't have the required privileges to perform this kind of attacks, we can use SQL injection vulnerabilities and use one of these attacks. Well, let's see now the first example with a demonstration, the method using an external procedure call. An external procedure is a procedure that is stored in a dynamic link library, in a function in a dynamic link library. So we first need to create a library of objects on the database that points to an external DLL file. And then we create a procedure that points to a function in that library. So there are some restrictions. In Oracle, we can't load libraries that are outside the Oracle Home lib directory in Linux and Oracle Home bin directory in Windows. But I found that there are interesting libraries in those directories that can lead to execute operating system commands. So we have, for Windows, we have the Visual C runtime library that has the system function to execute operating system commands. And also there is another library in Linux, the libos utils library, that has an exec function to execute operating system commands. So to perform this attack, we need to privileges, the create library and create procedure privileges. We just need first to create the library object inside the database. This is done with the create library statement. There are the examples for Linux and Windows. After we create the library object, we have to create the procedure that points to an exported function in that library. So here I create a procedure that points to the system function. And now I can use this OS-exec2 store procedure inside a PL/SQL program to execute the operating system command I pass as a parameter. So after I execute this to create library and create procedure statements, I can execute operating system commands as the Oracle user or system authority in Windows. So to disable Database Vault, we can execute these two statements that are the ones that you execute to disable Database Vault. And for Windows, we can execute any of these two statements. It is different if we are talking about Oracle 10G or Oracle 11G, because the DLL file name has the release version in its name. So let's see an example. Let's see the demonstration. This SQL script contains the statements that I just showed you. So we create a test user and grant create session, create procedure, and create library privileges. So this user doesn't have any database vault role granted, so it shouldn't be able to disable database vault or compromise database vault in any way. After I create the user, I create the library, the store procedure, and then call the store procedure that I just created to rename the DLL file. Look that we can use the environment variable, so we even didn't need to know where the Oracle home is located. So let's see. Let's execute this. This VM has Oracle 11g installed with DB Vault. Let's see first how the protections works. Let's suppose we want to protect the HR schema. I will connect as system, that is a DBA user, and select from that schema, and I will get all the results because the HR schema is not protected yet. But I will create now a realm to protect this schema with these statements. I connect as the database vault owner user and then create a realm. I give it a name. Then an authorized user for this realm, the HR user. Then I will say that it must protect the HR schema and all its objects in this schema, and gives a description of the realm. So after I create this realm, I will no longer be able to select from any table, even if I am a database administrator. I will get insufficient privileges. Error. But let's now disable database vault using this exploit. We are going to see here is the DLL. It just got renamed with an underscore. So the next time the Oracle instance is started, Oracle Database Vault will be disabled. I will restart the instance and check again if now I can access the HR schema. Well, it will, let's continue. It will take a bit to restart the instance. So there are a couple of things that we can do to protect against this attack. First, we can avoid granting the create library and create procedure privileges to user, especially the create library privileges. That is the one that allows to associate a database library to an external dynamic link library, or at least enable these privileges just for the period of time that is needed. Also, there is an interesting setting in listener Aurora file. The exproc DLLs setting can be used to restrict what libraries can be loaded. So we can just name there the DLL files that we know are secure and that our applications need. And no other DLL files will be able to be loaded. Let's see, it is still restarting the database. So we are next attack example that will get operating system access is the Java attack. There are two approaches that I will be showing today. One that doesn't require special privileges, and it uses the vulnerabilities discovered by David Litchfield this year, and that are fixed in April 2010 CPU. Or another way to do it is that using the functionality that is available to privileged users. The privileged users that Database Vault is supposed to protect from. Well, the database was restarted. Let's see now if the protections are still in place. I will connect as system and try to select from the HR. And as you can see now, I can select from the HR schema, so Oracle Database Vault was disabled. Let's enable it again so we can continue our demonstrations. Well, so there are basically two steps for this attack. For this attack that will use the Oracle Java functionality in Oracle to get operating system access. First, we need to grant the Java privileges that are required to access operating system resources. This can be done with in two ways. One is using the grant permissions store procedure, but this one requires the Java admin role. This is the official or documented way to do it. Or we can use the import JVM perms store procedure that are the ones that are with the Oracle Java vulnerabilities fixed in April 2010 CPU. So this method doesn't require any privileges because this store procedure can be called by any user. Then after we have the required Java privileges, we should create the Java store procedure that will contain the Java instructions to execute an operating system commands. These Java instructions are the standard Java for execute an operating system commands that will use the Java functionality to do that. Or we can use, instead of create this Java store procedure, we can call an existing Java class that Oracle had, the Oracle Aurora util wrapper class that contained a function to execute operating system commands. This one are not available if we have April 2010 CPU applied. So let's first see an example of using if we want the Java admin role. So we can use these statements to grant the necessary Java privileges. With these statements, Here I grant the necessary permissions to the one DBA user. After that, I create a Java source that will take one argument, that is the command that we want to execute. And then create a Java store procedure that will call this Java method, so we can use it in a PL/SQL standard program. So we could execute this statement to overwrite the sys password as any pass and to enable sysdba access, or we can use this other statement to rename the DLL file to disable database vault. Let's see how it works. Well, this script contains the same instructions we just seen in the slides. So we have the DLL file with the correct name. We are going to execute the exploit. And we will see that the DLL file will be renamed. Well, the way to defend from this attack is to restrict the Java admin role. That is the role that is needed to grant the Java permissions needed to access operating system resources, or to remove the Java support from Oracle database if we don't need it. Let's see if, well, as we can see now, the DLL files has an underscore, so it's the database vault will be disabled. So we were able to disable database vault having the Java admin role. Let's see now a way to do this with no privileges. It is needed just these two statements. The first one gives the necessary permissions, grant the necessary permissions to the user that is exploiting this vulnerability, and then we just use this function to call the Oracle Aurora util wrapper class, the main method in that class, and we just execute the operating system, pass as argument the operating system command we want to execute. Yeah, no, I will just show that it gets renamed. I won't restart and start it again. So the DLL now has the correct name. After I execute this exploit, we can see that the DLL file got renamed. So to defend from this attack, the one that doesn't use any privileges, we should apply the April 2010 CPU that fixes the Java vulnerabilities that allow to grant the Java permissions, even if we don't have the Java admin role granted. And or we could revoke the privileges from this DVMS JVM experms package that is the one that is used to grant the Java privileges. Well, let's see now an example how we can get operating system access and disable the database vault with a buffer overflow attack. This buffer overflow is in a store procedure, so we need execute permissions on a vulnerable store procedure. Well, this is the exploit. I won't enter much into detail. The vulnerable parameter is the dir path parameter. So when the buffer overflows, the EBX register points to the start of this dir path buffer. So here I enter the instructions that I want to execute, that basically are a call to the system function of C runtime library, and then the function, so that the threads end and there are no exceptions thrown after it continues with the execution. Let's see how it works. I will use 10G release 2 Oracle because this vulnerability is in that release. So we have the DLL file with the correct name. And as we can see, the file got renamed with an underscore. So now the database vault is disabled. Well, to defend from these buffer overflow attacks, Oracle fixes these buffer overflow attacks, the one that researchers report to them, or the one that they found internally with critical patch updates. So we can apply CPUs to be protected from known buffer overflow vulnerabilities. Also, it's important to reduce the attack surface, so we should restrict the execute permissions on packages, because there are a lot of packages with buffer overflow vulnerabilities. Let's move now to the impersonating Maxis attack. This one requires create any procedure and execute any procedure privileges. So it basically has two steps. First one is to create a procedure in the Maxis schema, and then we just execute this procedure which has created. As we know, the Oracle by default executes the store procedures with the privileges of the owner of the schema. So if we are able to create a store procedure in the Maxis schema, we can execute statements as this Maxis user. Here is the example. We just prefix the store procedure with the Maxis schema name. So this procedure takes a statement as an argument and executes it. After we have this statement, this procedure created, we can call it and with a SQL statement as its parameter, and it will be executed as the Maxis user. Let's see. So here the script first creates a test user and grant the required privileges to exploit this problem. We then connect as this user and create the store procedure in the Maxis schema and then call it to change the password of the Maxis user. As we are impersonating the Maxis user, we are able to do this. If we are not a Maxis user, even if we are DBAs, we can't change its password. And then I'm going to show that you can now connect as Maxis with this new password. Well, as we can see, here first I connect here. Here I can connect now with the Maxis any password use, any PSW password. Well, there are a couple of things we can do to protect from these attacks. First, we can restrict the privileges that are needed to perform this attack, that are the create any procedure and execute any procedure privileges. We should consider also to protect the Maxis schema with a realm. We can do that by executing those SQL statements. If we have the Maxis schema protected, then even if we have the create any procedure privileges, we can compromise the Maxis schema because it is protected with a realm. Well, there are some considerations that are documented for the sys user. But it's actually, the documentation doesn't say much about how the sys user can compromise. So I researched it a bit and found that it can compromise using this parse as user store procedure that can impersonate the Maxis user. So we can alter the Maxis password. And also in other releases, the Maxis user can do some other things like directly update all the data dictionary table. So for example, we can, if we are the sys user, we could update the Maxis password using this statement, or we can grant the DB owner role in adding a row in the sysauth dollar table. So what about SQL injection in sys schema? If we can impersonate the sys user using SQL injection, we can use some of the techniques I just mentioned to compromise database vault. Here is, for example, how we can do it with this vulnerability that allows to execute statements as the sys user. So we impersonate the maxis user with this parse as user function, and then after we have impersonated the maxis user, we grant the DB owner to any user. This is another example. Here, this SQL injection vulnerability allows to inject a function call. So I will need to create an auxiliary function that will contain all the statements that I want to execute as the sys user. Here I use another of the ways to impersonate the maxis user, and after impersonating it, changing its password. Well, Carson injection can be used in this case. This one is another example using a SQL injection vulnerability, but this time I will insert directly a row in the data dictionary internal table. This one is the same as doing a grant DB owner statement, but I just update directly the data dictionary table. Of course, if I execute here a grant DB owner statement, it won't work because the database vault protections are in place. Even if you are the sys user, you can't issue a grant statement. But doing this direct update of tables, you are able to grant the DB owner role. Well, this is a further analysis of the SQL injection vulnerability that we just saw, to see if we can exploit it without the need of an auxiliary function. We don't have too much time to enter into detail, but here I select from the $SQL text table to see what are the SQL statements that have been executed from the SGA Oracle memory. So I see where exactly the vulnerability is. Here in green, I can see that the parameter I insert is used here. So as we can see, there is a begin and an end. So we can just close this store procedure call with a parenthesis, and with a semicolon we could add other statements without the need of calling an auxiliary function. So here is how we could exploit this in a more simple way. And this is the statement that gets executed as sys. I wrote a white paper, so if you want to see more how this works, probably you could read it, as we don't have too much time. Also, there are some vulnerabilities more specific to the database vault implementation, because actually the ones we've just saw take advantages of the functionality that the Oracle database provides to be able to compromise database vault, but there are also some vulnerabilities specific to database vault. One that was fixed some time ago, that when we changed the language session parameter to anything different than American, the database vault realm protections for DDL statements didn't work. And there are also some pending fixes that I reported to them, and they are going to fix Well, this is like a similar subject, but not directly related to database vault. There are some issues with the sys user auditing. As it is documented, the sys user is audited in a different way than regular users. They are all the statements that we execute as the sys user are audited with the SQL text as we enter them. So, for example, if we call a store procedure as sys, we don't see all the. We just see the exec store procedure, and we don't see all the things that the store procedure executes. So what about SQL injection running as sys? If we can exploit a SQL injection that is in the sys schema, we could execute statements without being audited. Well, there are some additional protections measures that we can take. First, restrict the system privileges that can lead to full database compromise and the compromise of database vault, the become user, and those other privileges mentioned there. This SQL statement can be used to retrieve all the users and roles that have these dangerous system privileges granted. We should take into consideration that we should never use the default Oracle users or roles. It generally contains a lot of system privileges, and they may change over time. We should create our own roles and grant the roles that the privileges that we know that are needed for the job. But there is also a way to change the external job operating system user. If we change it to a low privileged user and not the Oracle or system user, we can protect that. If we create a job operating system, an external job, we can't access this DLL file or execute the commands to disable the database vault. Well, some conclusions. We just saw the separation of duty that is provided by Oracle Database Vault can be bypassed. There are some system privileges that can lead to full compromise of the Database Vault installation. As we have seen, if we find and exploit a vulnerability, a SQL injection vulnerability in the sys schema, we are able to execute as sys SQL statements as sys, and we can compromise database vault or even execute SQL statements without being audited. So I think that Oracle should move out of the sys schema much of the functionality and use only the sys schema for the core and most important part of the database. Also, I have been studying Oracle Database Vault for a while, and I have seen that its security is improving. It's also easier to use. It has more restrictions for the sys user. There are more tools that are compatible with Database Vault. So these are positive things. Well, in the white paper, you can find some more references and information. So that's it. If we want to